Alright, in this tutorial I'll be showing you how to blink an LED with your MSP430, basically the Hello World program for a microcontroller. The first thing you want to do is go to your favorite text editor and open a new file. We'll call it blink.c, and it won't start off blinking, but we will do so later. The first thing you want to do is include the MSP430 header. Open up your main function right here, and now the first thing that we'll need to do with this microcontroller is to hold the watchdog timer so it doesn't reset. Now the watchdog timer is a built-in piece of hardware that will reset your microcontroller in case it causes an error during your program. So in this case we don't care about any errors, so we're just going to hold it so that it doesn't reset the board on us. This is useful mainly for production environments where you want to make sure nothing goes wrong, but for experimenting it's fine to just go ahead and hold it. The different components here: this is the watchdog timer password, this is the hold instruction. So setting this whole thing into the watchdog timer control register shuts it off, so we don't have to worry about it. The second thing we'll need to do is to calibrate the microcontroller to run at 1 megahertz. And you'll need both of these lines to do so. Now the MSP430 generally wants to run by default at 16 megahertz, but in using these lines you can tell it to run at a different speed. So in this case we want it to run at 1 megahertz just because we don't need it to run at 16 megahertz. It's just a waste of power. There are other settings for 8, 12, and obviously 16 megahertz. Alright, so after we have all that set up, we'll go ahead and set our port pins. So what I'm doing here is firstly setting the output direction for port 1 pin 1.0 to an output. If it was a 0, it would be considered an input. By default, all of the port pins on the MSP430 are inputs. So in this case we want it to be an output so that we can turn on an LED. And here is the actual toggle for being on or off in the P1 out register. So in this case we're going to be turning the port 1.0 pin on. And then we will just return 0 to allay any compiler warnings. Go ahead and save that file and move to the directory that you saved it in. In my case it's the tutorials directory. Then we'll be using the MSP430-GCC tool to compile it. You'll need to give this tool the -mmcu equals and then give it the architecture for the chip that you're using. In this case we'll be using the 2553. You need to specify the output file with -o. We'll just name that blink.elf, and then finally type in your input file, which should be blink.c, and then hit enter. Now if we list the directory again, you see that it's compiled into the blink.elf right here. And to actually program that resulting code to the board, we'll use the MSP debug tool. Now when using this tool you always need to specify the communication type that you'll be using. RF2500 is basically telling it that you want to use the USB cable to the board to program it. We can simply run this to get dropped into a command line, provided you have your board hooked up, of course. We'll go ahead and quit out of that using Control D right here, and instead we'll just go ahead and provide the command that we want in single quotes right afterward. In this case, we want to prog for program, and then give it the file name, blink.elf, and press return. Now after all that goes by, it's common to see an FET error right here. That's no big deal. It should usually restart it and then continue on. If it's finished successfully, you'll see the program here. It wrote 110 bytes to our text section and then 32 bytes to our vector section with 142 bytes total. Pretty small program. Now we'll go ahead and move to the board and show you this working. Alright, as you can see on the board, the red LED is currently on. Go ahead and flip the light on. And as you can see right here is the P1.0 pin. This is the pin we are affecting in the program. In parentheses, there's the words LED1, which corresponds to this first LED here. There's also a secondary LED. LED2, its corresponding pin is right here, P1.6. Now to just cover some simple electrical concepts, we'll be looking at a terrible drawing of an LED that I did. You can find a couple of these in your kit. If you look closely on the inside of the LED, there's a smaller and larger piece. There's a bridge here with an element right about here that's actually doing the lighting when you turn one of these on. So this smaller side is the positive and the larger side is negative. Also, the longer lead is the positive side, whereas the shorter one is negative. Sometimes these are referred to as anode and cathode, and if you've ever seen an electrical schematic, an LED is drawn like this, with the positive anode side coming in here and the cathode side on this side right here. Now if you don't know electrical concepts that well, it's not a big deal, but it's easy to think of powering an LED as, you know, affecting the P1 out register, setting it 0 or 1. If it's 1, that means this pin is powered and the electricity wants to flow down to ground, and in doing so it will cross the LED, causing it to light up. Whereas if you had it set to 0, since there's no difference in elevation here, there's no flow of electricity. That's a very simple way of looking at it, but that's basically all you need to know to get past this class. So P1 out to 1 to get the LED to turn on, and keep it 0 to turn the LED off. Alright, now we'll go ahead and wire this thing to the board. You should find one of these small breadboards in your kit, as well as a couple of jumper wires. The wires have female ends as well as male ends. These ones will be going to your launch pad, and the male ends will be going into the breadboard. So the first thing we'll do is go ahead and put the board here, and we need to pull one of these ground pins to the board. There are 3 of them. It doesn't matter which one you choose, they all do the same thing. So I'll just pick this one and put it here, and then take this port pin and do the same. So P1.0, and we'll put it right next to that. So now we have our ground on the left and our power on the right. We'll just go ahead and mirror the setup that we need. So the ground to the left side and the power to the right, and push the LED into the board, and as you can see, it will light up. Now it's worth noting that you could also connect this wire to the VCC pin, which is just straight power. There's no program to affect whether or not voltage is going through that or not. This isn't recommended. You can blow LEDs by doing this. So if you need to power anything, the best way to do it is to set up a small program to turn the pins on that you need, and then wire them to the board correctly. Okay, now that you've got an external LED wired up to the launch pad, let's go back to this program and take another look. Now for these two lines, you'll notice I've used this syntax 0B followed by 8 bits with the last bit turned on. This corresponds to P1.0. Now we could have written it like P1 out equals OX01, which would be in hexadecimal, the same number, or in this case you could even use just the number 1. The MSP is set up so that you can address multiple pins on the same port at once. So if you wanted to also turn on the green LED, you could write, let's see, 1, like that. So this would be the 0th bit, and the P1.6 would be this number right here. Now with that out of the way, let's cause some action on the LED. We're going to use an infinite loop here. You've probably seen a for loop before. In C, if you have an empty clause here in the for loop, this causes it to run infinitely. Another way to do this would be to write while 1. These both do the same thing, so whichever one you prefer, it's not a big deal. But inside here, let's go ahead and set the LED to off, and then we will use a built-in function called delay cycles, and we'll set it to 1 million. Now since we're running at 1 megahertz, this means the processor will do 1 million cycles a second. So delaying it by 1 million is effectively 1 second. The built-in processor can be kind of inaccurate, so it's not always sourced for timings like this, but in our case it's fine. Right here we'll go ahead and turn it back on, and then delay 1 million cycles again. So as you can see, it will start at this point and set the processor up. Then it will go ahead and set the P1.0 pin to an output and turn it on, and our for loop will immediately turn it off, delay about 1 second, and then turn it back on and delay another second, and then this will happen over and over forever. So go ahead and save this program and use the same commands to build it again. And then flash it to the board. And now if you look at your board, you should see both the onboard LED and the external LED blinking at about 1 second. Now we can improve this program a little bit using some bit commands. Instead of just setting it manually both times here, we can just use a single instruction and tell it to toggle using an exclusive OR. And this will have the same effect. What this tells the processor is to take whatever's in that last bit, and if it's off, turn it on, and if it's on, turn it off. That's what the exclusive OR will do. If you're not familiar with bit math, it's not a big deal, but just know that that instruction will flip the LED on or off depending on the current state. So go ahead and just build that again and flash it to the board. And if you had flashed the previous program, you'll notice really nothing has changed. It will still just be blinking. And there you go. That's just a simple hello world for your MSP430 to blink an onboard or external LED.